Hello students, I am Dr. Tanmoy Biswas. I welcome you all in my channel Chemistry, the Mystery of Molecules. Today's topic of discussion is about one aromatic compound you can see here. So here actually student 4 steps of reactions are carried out. So I suggest you make your mind cool, think properly, take time and try by yourself, and whatever answer you get please write in the comment box. Actually, you have to say that what is the major product of this reaction, and for that purpose 4 options are provided, and actually one of them is the right answer. It's an interesting problem. So I believe you have tried by yourself. It's my turn to give you the right answer. So if you look at stepwise, that these molecule have one aldehyde, fine, which is another part. If you look at, there are 2 hydroxyl group. So here actually mainly if you look at functional groups point of view, 2 types of functional groups is that carbonyl means aldehyde and hydroxyl. What is the first step? DMAP, dimethyl aminopyridine, trithylamine. So and TBDMSCl. What is this reagent? Actually TBDMSCl means actually it's a silyl chloride, dimethyl and 1 tertiary butyl. So this reagent is student nothing but protection of alcohol. It is a relatively bulky silyl protection for alcohol, and during this protection what it produces, that one molecule of means 1 unit of hydrogen comes here, and after protection this Cl comes, so it produces 1 unit of HCl, and in order to quench that, this DMF trithylamine combination works. Okay, so 0 degree centigrade DMF, it's a pretty milder reaction condition. So in this way primary alcohol protection happens. So like as usual I explain that, okay, if there is multiple number of steps, first focus on the first steps and go slowly. So whatever we told that this silicon protection, it is made here, and obviously ammonium salt, because H produced HCl is quenched. Now in the next step it is actually interesting, and it has a name, Corey-Fuchs reaction. So I'll upload a dedicated lecture on it, please visit. Now what this done, actually this carbon tetrabromide triphenyl phosphine, you can consider it is a analogous of Wittig reagent or Wittig reaction. Okay, so what it will produce, it will produce one carbanion, means actually ylide, more specifically if I say this is CBr2 minus PPH3 plus. So this CBr2 can act as nucleophile. Now in the first step both hydroxyl are protected as this TBDMSO. Now what is left? Aldehyde. Now you can say that, sir, this nucleophile part, carbon is attached to bromine, 2 bromine atoms, means it's a bigger bulky nucleophile. It's true, but if you look at the carbonyl point of view, it's aldehyde, less bulky. So reaction happens, and we know that Wittig type reaction converts carbonyl into alkene. It's a double bond formation reaction. So here the double bond or alkene formation occurred. Fine. In the next step, what's there? In next step, this LDA THF minus 17 is a strong base condition. So this strong base resulted in, actually first it abstracts these, you can see this bromo. So if I say LDA, lithium diisopropyl amide, generally we say LDA act as a base, obviously it acts as a base, but in this case it reacts differently. So N minus attacks here. So after that it produces a negative charge. I am drawing here, student, so negative charge. And in the next step what you can think, that in the next step these bromine leaves, means you may consider it's an alpha bromination type reaction. So what it produces? It produces, student, here one carbene type derivative, double bond. Now because of this what happened, this proton got abstracted. How? This lone pair comes here and this proton shifts from here to here, and in this way it produces this terminal alkyne. So actually in the first step terminal alkyne is not produced, student. More accurately if I say, this salt and lithium plus is produced, which upon workup with this dilute HCl produces the terminal alkyne. So here terminal alkyne is produced. So this is, now here another question, why the silyl ether did not undergo deprotection during the reaction condition? Now you can think that, sir, silyl ether, actually we have taken a very bulky silyl ether here, tertiary butyl. So nucleophilic attack on the silicon center not possible. Option 1 gone. So these nucleophile means this ylide can't react with this silicon center. Even LDA is a bulky base, so it will not attack, obviously, it's sure. Now you can say that there is dilute HCl. So it is not that much stronger to hydrolyze this silyl ether. And actually one thing student remember, if the silyl group is bulkier, it is strongly protected, so breaking of this silicon is difficult. Now this is the answer, but for your curiosity, if you ask that, sir, how can you remove this, there are many methods. For example, the most I like personally, that is fluoride method, mediated method, or quaternary ammonium fluoride. If you add, that will attack the silicon center, and here deprotection will happen and it will produce this OH. Okay. So if we say the key steps and name reaction, first step is alcohol protection by silyl ether formation, or better to say bulky silyl ether formation, this TBDMSO. Okay, fine. And next step is Wittig type reaction, or actually if you consider that this total step number 2 to 4, it's actually Corey-Fuchs reaction. So in this way, from aldehyde to terminal alkyne is produced. So for your better understanding, this is the reference, there is a sequence of reaction is given. This for the authenticity I have provided. Now what is the right answer here? Here obviously terminal alkyne, only one option is given. Okay, now a simple question, student. If this question appears in your exam, it's a difficult question, I agree. You will say how can you get the right answer in less than 30 seconds? Now simple one. So this is a silyl protection, first step, silyl protection of these two alcohol. Second is ylide. Third is LDA-THF, dilute HCl. So under this condition, is silyl ether deprotection possible? Obviously not. So option A and B gone. Now option C and D. By the way, student, I suggest you, these are the tricks, but please study, don't follow the tricks only. Now in the next step, there is a, so we understand the silicon protection will be there. Now alkene versus alkyne. So from this reagent, this is actually ylide formation. So what it will produce? It will produce not these alkene, it will produce these bromo containing alkene. So and LDA, what base can do? Base can result in elimination. So these will not be stable. So which option left? Option D. So if you don't know also, you can get the right answer by proper choice of elimination. Okay, actually this is called the selection by elimination. So this is a good strategy for MCQ in exam hall. Now in conclusion, what you have learned today, that alcohol can undergo silyl ether protection by silylation reagent like R3SiCl. If the R group is bulky, then silyl ether preparation and protection both are difficult. So you may consider if protection is difficult, then deprotection is also difficult. And these silyl ethers are stable in organic reaction medium, and it could be hydrolyzed by very strong acid or strong base or methyl lithium or fluoride, and my personal choice is fluoride because it's milder. Now Corey-Fuchs reaction, which we have discussed some time before, it produces dihaloalkane in the first step, subsequently it undergo alkyne conversion in presence of strong base through carbene as intermediate. And finally, so this terminal alkyne CH bond is significantly acidic due to sp hybridization of that carbon, and that's why to get not alkene, it is alkyne. To get alkyne acidic workup, means mild acidic workup is essential. We may add water also, that is enough. So this is the end of discussion. I believe this video may be useful. I thanks everyone for watching this lecture, and if you really consider the content of my channel is worthy, then please help this channel to grow. Stay happy, stay blessed. See you in my next video. Bye bye.